Lesson 28, simplifying rational expressions. So we'll just start out with what a rational expression is. It's just a quotient of two polynomials. So the quotient of two polynomials is a rational expression. A quotient just means a fraction. So here's an example. 4x squared minus 10x plus 6 divided by negative 2x squared minus x plus 3. Whenever you're given a rational expression and asked to simplify, there's a couple of things you want to do. You have to remember to cancel factors, and only factors. Don't cancel addends or subtrahends or minuends. They have to be factors, which means you've got to factor both of the polynomials. Another thing to remember is the denominator cannot equal 0. So what you need to do is find the excluded values, which is just a value of x that makes the denominator equal to 0. And then we need to exclude them. In other words, they can't be that. So an excluded value is a value of x that makes the denominator equal to 0. So in our example, if we wanted to find the excluded value, we take the denominator and set it equal to 0. And we solve for x. So when we factor, we get negative 2x minus 3 times x minus 1. And then, because it's the 0 product property, we set each of those equal to 0. So negative 2x minus 3 equals 0, or x minus 1 equals 0. So we add 3, divide by negative 2, and we get negative 3 halves, or x equals 1. These are the values that are excluded, because when x equals these, the denominator would be 0. So these two values are called excluded values. And that's going to be part of your answer, that x cannot equal those two numbers. So here's another example that we're going to simplify. 10, 4 minus 3x over 15, 3x minus 4. I can reduce the 10 and the 15 to get 2/3. And then if you notice the polynomials or the factors that are in parentheses, they're very similar, except that the signs are different. This 4 is positive, this one's negative. 3x negatives, this one's positive. If I take out a negative 1 out of the denominator, we'll just take it out of the denominator. So if I factor out a negative 1, so that will be a negative 3 out here. This becomes a minus 3x, and this one becomes a 4. Now they're the same, and I can cancel the 4 minus 3x, and I get negative 2/3. So this particular quotient equals negative 2/3. And one thing to remember in this case, x cannot equal 4/3. If I were to set this equal to 0, x equals 4/3, so x cannot equal 4/3. So my answer would be negative 2/3, and x cannot be 4/3. So that's part of the answer. Circle like that. The quotient of powers property. Just says that if you are dividing and you have the same base and their exponents, you subtract the exponents. Now you could subtract it the other way, where you leave it in the denominator and you have 1 over x to the a minus b. So a lot of times I'll find the biggest exponent and then subtract and leave it either in the numerator or the denominator, depending on where it's at. So for instance, if I had x to the 6 divided by x squared, I'm just going to subtract 6 minus 2, that equals x to the 4th. If I had the inverse of that, x squared over x to the 6th, I could do it this way, where I have 1 over x to the 6 minus 2, or x to the 4th. And that will keep my exponents positive if I do it that way. And that's the end of the lesson.